folks, let's take a look at number 10. This time I've got a rational inequality, and I got to figure out where this thing is less than or equal to 0. The upside is that this is pretty much already factored. I don't have to factor it much, but what I am going to do is I'm going to set both numerator and denominator to 0. Then I'm going to put those numbers on a sign pattern, and we're going to see where all the positives, negatives, and zeros are. So if I want to start my sign pattern, let's set my numerator to 0. Right? And then let's also, and I'll put another little separation, set my denominator to 0. And when I add the 3x to both sides and divide by 3, when I work that, right, I would have 3x equaling 15 here. So that's going to give me what x is 5. I'll keep that in mind. And here, if I move the negative, well, I'll subtract 1, and I'm going to get x equaling negative 1/6, right? So those are going to be the two x values. Sometimes we refer to those as like critical values. They're just critical to the problem. And since negative 1/6 is smaller, I'm going to put that to the left of 5. So let's go ahead and make a smushed xy axis. So I'm going to put my x coordinates here, and I'm going to put 15 minus 3x over 6x plus 1 here. All right, so I'm going to have a negative 1/6 and a positive 5. Okay, when x was negative 1/6, that made this expression have a 0 in the denominator, and you can't have a fraction with 0. That y value or that fraction's value does not exist. Okay, when x was 5, the value of this fraction, this rational expression, 5 would zero out my numerator. And anytime you have a fraction where the numerator is 0, that fraction itself is 0. Okay. All right, so then we can play the use test points or lead coefficients and see if things alternate. I'm gonna go ahead and I'm gonna do the test points one. I think the test points one, especially with fractions, is probably it's a better starting place. And then I'll show you the quote unquote shortcut. So let's try a test point. I'm gonna pick 6, okay? If I plug 6 in to my numerator, right? 15 minus 3 times 6 is a negative number. 6 times 6 plus 1 is a positive number. A negative over a positive is gonna leave me with a negative, all right? Now let me pick a test point of 0. All right, 15 minus 3 times 0 is a positive number, right, because it's 15. 6 times 0 plus 1 is a positive number. A positive over a positive is positive. I'm going to pick something like negative 2 here. All right, 15 minus 3 times negative 2 is going to be positive. 6 times negative 2 plus 1 is going to be negative. Positive over a negative is going to be negative. So I want you to see I had a lead coefficient or a lead negative if I start from the right and move left, and then I alternated. Now the way I could have discerned that without doing these test points, and let me go ahead and erase my particular test points. You might have different test points. Not a problem there. Is this. So I would look at the lead term in the numerator in ratio to the lead term in the denominator. And I have negative 3 over negative 6, right? If I reduce it to just that number, right? But negative 3 over negative 6 is negative. So I would know there was a lead negative. If you look at the highest degree terms and just take a ratio of those coefficients, if that ratio is positive, you put a plus sign here. The ratio in this case was negative, I put a negative sign here. As I head to 5 came from the factor of 15 minus 3x, or really x minus 5 was in here. But this had an odd degree, so I knew I was going to alternate. I knew I was going to go from negative to positive. All right, negative 1/6 came from this denominator, which is technically, right, it's got a binomial with an odd degree. Anytime you have an odd degree, you're going to alternate signs. So I knew I was going to move from plus to minus along that. So that's personally how I do it now. And I don't mean that in a braggy way. I've just been doing this for a while, right? So I look, okay, I have a lead negative coefficient, negative. All of these factors were basically to odd powers, so I knew I was going to alternate. Okay, but at the end of this, it's this symbol that we got to go to. So I want less than or equal to 0. So I want to collect all the negatives and all of the zeros. So I see negatives here. I see a 0 here and another negative. So I want to collect that 0. I'm going to put a bracket here. This doesn't exist, so it has to be a parenthesis. So when I start to look at my answer, it's going to go from negative infinity, negative 1/6 in parentheses, because negative 1/6 is the D and E. 5 exists, so I'm going to include it. And then we go from 5 to infinity. So that's going to get me to C is my answer. All right, thanks so much. Bye.